Yeah, hello guys. In this video, we're going to discuss the weekly contest 370 problem C maximum score after applying operations on a tree. So this was an interesting problem, not too hard, a little bit implementation. We had to know, like I solved this problem using DFS. So if you know DFS and you just get the idea that we have to apply as DFS in a certain way, not in a very unique way, we can actually solve this. Not a unique way, but but it's kind of like little bit tricky, very little tricky. We can solve this problem very easily. So they have given us a tree and the nodes are labeled from 0 to n minus 1 and rooted at node 0. You are given a 2D integer array edges of length n minus 1, where edges of I is equal to ai bi indicates there is an edge between nodes ai and bi in the tree. You are also given a 0 index integer array values of length n, where values of I is the value associated with the ith node. You start with the score of 0 in one operation. You can pick any node I, add values of I to your score, set values of I to 0. A tree is healthy if the sum of values on the path from the root to any leaf node is different than 0. Return the maximum score you can obtain after performing these operations on the tree any number of times so that it remains healthy. So these are the nodes. These are not the node values. These are the just the node numbers. The values will be given in another array. So this is the value of the 0th node. This will be the value of the 2 will be the value of the first node. 5 will be the value of the second node for this particular tree. And we have to apply operations such that we can. So initially our score is 0. We can take the values of some nodes and add it to our score, but then the node that we take the value from will lose its value. We have to return the maximum score such that the tree remains healthy. The tree remains healthy such that, like, if we go from the root, so there are three leaf nodes in uh, this tree. So if we go to this leaf node, there is the sum of the path. The sum of the values in the path should at least be non-zero. There should be at least some value present there. And likewise, when we go to all the leaf nodes, there should be some value along the path. So one of the first idea that comes to our mind is that let's strip all these nodes except the root node of its values. Okay, that's but actually like so if we strip all these nodes of its value except the root node, the root since the root node have some value, when we go to this leaf node, there is a non-negative, non-zero value. When we go to this leaf node, there is a non-zero value since root node has a value. When we go to this leaf node, there is some value along this path since the root node has some value. So that's actually a pretty good idea for this first test case, for this first tree. The optimal solution is actually that. We can choose the node 0, 1, 2, 3, 4, 5, and we can strip all those nodes of their values. Then the total value that we will get will be 11. We will let the root node have the value, let the root node have the value to itself. We will not take the value of root node. The value of the root is not 0, hence the sum of the values from on the path from the root to any leaf is different than 0. However, the tree is healthy and the score is values of 1 plus values of 2 plus values of 3 plus values of 4 plus values of 5 is equal to 11. It can be shown that 11 is the maximum score obtainable after any number of operations on the tree. Okay, actually that is a pretty good solution for the first. But the problem arises if suppose you know suppose the root node have a very high value, and even so suppose the root node have the value 12. The values added up of all the other nodes only will be equal to 11. So if we are stripping, we are letting root node keep its value. We are losing on a, suppose this 5 is 12. We are losing on a large value. So that is not acceptable. So we are losing on a large score. Yeah, so that's not acceptable. So the approach that I came to solve this problem is that I will start from the I will start from the bottom of the tree. Actually not the bottom of the tree. Like I will start from the I will apply the DFS from the root node. Then I will come to the bottom. Then I will backtrack. Then I will backtrack to the root of the tree. So actually, the operation, the logic starts from the root of the tree. The DFS starts from the top. So actually, like I let all the leaf nodes keep its value. I will let all the leaf nodes keep its value, and I will strip all these values out. Since all the leaf nodes have the value, any path from the root to any leaf node is non-zero. And suppose let's consider this subtree. These two leaf nodes have some value. Okay, and we are coming to this node. Suppose the sum of these values is greater than the value over here. The sum of these values is greater than the value over here. We are losing on a greater value. So that's not acceptable. So we will strip these two nodes of their values and we will add that to our score. Instead, we will let 2 keep its value. We will say to 12, okay, you keep your value, but I am taking the 6 and 5's value with me. And here I will let 3 and 5, 3 and 4 keep its value initially. But when I go to 1, I will check whether the values added up of 3 and 4 is greater than the value of 1. If it's lesser than 1, taking the value of 1 is optimal because if the values added up of 3 and 4 is lesser than the value that is present in 1, it is better to take the value of 1, right? Uh, so I will let 3 and 4 keep its value. So likewise, I will go up till the zeroth node, the root node, and I will do this operation along all the way. So that's what I have done over here. So okay, I will show you the code. So initially, I am creating an adjacency matrix. I think you know how to make an adjacency matrix, and I'm gonna create a visit array, and then so while considering the DFS, I am trying to minimize the sum that minimize the minimize the value that I am allowing them to keep. So I'm trying to minimize the values the nodes are allowed to keep. So such that the values that I extract from them will be larger. So I'm considering a sum. I'm adding the sum of all the values. Then I'm running a DFS. So since DFS is the DFS returns the values that I'm allowing the tree to keep, the sum minus the values that I'm allowing the tree to keep will be the maximum value that will be present in the score. So I'm running the DFS then. In each recursive call, I'm setting the visitor when we reach a particular node, I'm setting the visitor of that node is equal to 1. Then I'm declaring a boolean variable sum, and I'm checking whether this is a leaf node or not. So initially, I'm just giving this as true. Uh, uh, okay, this is a leaf node. This will not be a leaf node if we go through this for loop. If we go through this for loop, we will know that okay, this particular node have some children, so it has to go through this for loop to go get to its children. So we will make the check as false. But if the check is equal to true, I will tell you if the node is a leaf node, we have to do something else. Okay, this is the standard DFS code. Uh, for a particular node, I am taking the sum that is been returned by all. So suppose like here, so suppose we are at this, um, suppose we are at this node. The sum here will be equal to the sum of the values that I am allowing my children to keep and the children to keep. So suppose this will be a larger tree. so I have allowed the children to keep some values over there. So I will be returning those values, and 2 will represent the sum of those values. Then I will compare the sum that I'm allowing the children to keep with the values of the 2, and I will check which is minimum, and then I will return that. If the sum is minimum, I will return sum. If the values of I 2 is minimum, I will return that. That's why I'm considering sum here. Then if it is a leaf node, we will just return the values of node, because since it's a leaf node, there will be no sum. So we will directly return the values of node, and else we will return either which we will check which is the minimum, the values of node or the sum. We will return the minimum value. Likewise, we will find the minimum value that we can keep in this tree such that it will remain healthy. Yeah, that's my solution to this problem.